You know that feeling when you're waiting for an AI chatbot to answer and you're just staring at that blinking cursor? Well, NVIDIA just dropped a paper on a brand new architecture that could make that frustrating lag a thing of the past. Let's break down how they're literally teaching AI to think before it talks.
It's a feeling we all know, right? You ask a really complex question, and then you just wait. That delay, what we call latency, is one of the biggest headaches in AI today. But to really get why it happens, we need to pop the hood and see what's going on inside.
So the whole problem, the real speed limit for these AIs, it all comes down to how they generate language. It's this incredibly tricky balancing act between making perfect sense and actually being fast.
See, most of the high-quality models you use every day, like ChatGPT, they use what's called an autoregressive, or AR, approach. It's super meticulous. They generate text one, single, word or token at a time. Now, this step-by-step process is great because it makes sure the output is coherent and really high quality. But as you can probably guess, it's also incredibly slow.
I mean, think of it like this. An AR model is building a huge, complex Lego sculpture. It's carefully placing one single brick at a time. Every single piece is placed perfectly, but building the whole thing takes a very, very long time.
And that leads us to this fundamental trade-off, this huge problem that has defined AI text generation for years. Basically, developers have been stuck choosing between two options, and neither one is perfect.
So on one hand, you've got those slow and steady autoregressive models. On the other hand, you have something called diffusion models. Now, if AR is like building with Legos, diffusion is kind of like starting with a really blurry photo of the final sculpture and slowly trying to bring it into focus. It's way faster because it works on the whole thing at once, but the details can get pretty messy, which leads to lower quality and a lot more mistakes.
So for the longest time, this was the choice AI developers had to make. You want it fast, or do you want it right? You couldn't have both. But what if you could?
All right, so this is where things get really interesting. This is where NVIDIA's new research comes into play. They've come up with a new hybrid architecture they're calling TiDAR, and it's designed to completely break that trade-off.
The researchers at NVIDIA decided to tackle this problem head-on. They were like, okay, how can we get that super fast parallel generation speed without giving up the amazing quality we get from autoregressive models? And their answer is TiDAR.
And their whole idea is captured in this one brilliant phrase: think in diffusion, talk in autoregression. What does that mean? Well, the model thinks super fast, using that diffusion method to brainstorm a whole bunch of possible words all at once. Then it talks by using that precise autoregressive method to instantly check the draft and pick the absolute best one. It's literally the best of both worlds.
Okay, so that sounds great in theory, but how does it actually work? Well, the secret is pretty wild. It's not just some new fancy algorithm. It's about being super clever with the hardware we already have.
Yeah, it turns out that when a regular AR model generates just one single token, it's barely even using the full power of a modern GPU, something like an NVIDIA H100. There's just this ton of leftover computational power just sitting there, completely unused in that single step. TiDAR is designed to grab all of that free compute and put it to work.
And this chart right here shows you exactly what I'm talking about. Look at this. To process just one token, it takes about 35 milliseconds. Okay, makes sense. But now look at what happens when you process 16 tokens. It only takes 37 milliseconds. That's almost no extra time at all. Those extra 15 slots are basically free. And that is exactly what TiDAR uses, these free token slots, to do all its thinking and talking at the same time.
So let's put it all together, right? In one single computing step, TiDAR does two things. First, it thinks. It uses its diffusion side to draft a whole bunch of potential next words in parallel. Then, in that exact same step, it talks. It uses its autoaggressive side to check all those drafts and pick the right ones. It's like a brainstorm and a fact check all bundled into one incredibly efficient move.
Okay, so the concept is super elegant, but does it work? Oh yeah. The performance results are, well, they're pretty staggering.
You gotta hear this. On an 8 billion parameter model, TiDAR cranked out text almost 6 times faster than the normal version. I mean, that's not just a small bump. That is a massive leap forward. And the most important part? It did it without losing that high level of quality. The trade-off is officially broken.
And this table really puts it all into perspective. You've got your standard AR model, that's our baseline, 1x speed. Then you've got diffusion models, which we know are faster but lower quality. There's another cool technique called speculative decoding that gets you about a 2 to 3x speedup, which is pretty good. But then, look at TiDAR. It just blows everything else out of the water, hitting almost 6x the speed while keeping that top-tier AR-level quality. It's not even close.
So what's the big takeaway here? Why is TiDAR such a game changer? Well, first, it really does give you the best of both worlds, diffusion speed with AR's quality. Second, it does all of this inside a single unified model, which makes it super efficient. It completely outperforms the other speed-up tricks out there. And maybe one of the best parts? It just works. Right out of the box, no need for a bunch of complicated fine-tuning.
This is a huge breakthrough, right? It really pushes the limits of what's possible with real-time AI. It really makes you wonder, now that AI can think as fast as it talks and that frustrating lag starts to disappear, what new kinds of conversations and tools are we about to unlock? The future of AI just got a whole lot faster.